Welcome to my quick intro of Rhinoceros. I'm gonna show here some of the tools you can use, but of course one has to also try oneself a little bit and look at all the options available. I'm gonna open the toolboxes, and you see here, for example, there's a lot of curves. So I'm gonna show some of them, and we're gonna draw something. But not all of them, of course. Then you have to explore them a little bit yourselves. Yes, so while I'm talking, it would be great if you could also open Rhinoceros and draw similar to what I do in this video, so that you get your own feeling for the software. So we are working with Rhinoceros, which is a NURBS modeling program. A lot about the program can be also read here on the Rhinoceros forum. If you have questions, you should remember this address, discourse.mcneil.com. You can also go to rhino3d.com, where everything is more explained. There's a lot of read here about the software itself. So Rhinoceros is built from non-uniform B-splines, which are abbreviated as NURBS. You can go here to see on Wikipedia, for example, non-uniform rational B-spline. That means NURBS, which is used in many CAD programs in 3D and is practically vectors. Here you see a typical NURBS curve like this. Control points, and a curve is drawn here as an approximation of these control points that have been drawn. This can, of course, this is a 2D image, but it's of course possible to do that also in 3D. And these curves are the basis for building other geometries, such as surfaces, polysurfaces, and whatever you can imagine to build. So you see the origin is, for the curve itself, is points, coordinates in Euclidean space. They together form a curve, and the curve can later then build the surface. For example, you can also build surfaces from coordinates, of course. So that's a little bit of overview, what's it about, and here we have the whole interface. So as you can see, we have a command line up here. That means you type a command in here, and then you get questions back. For example, I can type curve, and a list of suggestions comes out, right? And if I click curve, the program will ask me start of curve. That means where should I start drawing my curve, right? And we have also additional questions, and you see here, if you click them, you can actually change the degree of the curve. I will talk about the degree later on, but you can now already answer the question by clicking in some of these windows. For example, like this. You continue clicking until you are happy with the result, more or less, and then you click either enter on the keyboard or right click on mouse. So that's more or less like how you do it. So what about these viewports? We have a top view here. We have a front view. We have a right view, and we have a perspective view. And you notice now that I'm actually moving these, and that's by clicking the right mouse button. So in perspective view, the default settings are that you will rotate around an object, rotate the workspace like this. And in the other windows that are 2D, you know, it's a 2D view, if you right click, you pan. And also in all windows you can scroll with the mouse wheel to go back and forth like this. So if I would draw a box, like for example here, you will see in all the viewports what's happening. You see it's moving now. It's because it's the transformation I'm doing is only happening in the Z direction. That's why it's visible only in front and right view. And they look differently sized, of course. It's because I've zoomed before. So this is the setup. Top view, front view, right view, and perspective. You can always change these viewports. If you want to have left view, you can actually go in there and set view and go to left. You can even look from the bottom view if you want to. So all those viewport settings are by right-clicking here on the name of the viewport. Yeah, and deleting this object, I simply select it with the mouse, with the left mouse button, and hit delete, then it's gone. If we jump to the right, we have other settings like properties. That means, for example, now it's on the viewport actually being described in the properties. So every time I move around here, you see that X and Y and Z location changes, right? I can also, if I draw a cube again here, I can also select this, and then the properties come out completely differently, because now the properties are describing this very geometry that I selected, right? So I can have display color or something else, for example. And if you choose a display color, you must know also that we can look at this in the perspective view a little bit differently. Like, for example, now I picked ghosted, which is a very good feature because it's like semi-transparent, still showing some shadows. That will give you more a feel of the geometry itself. You can also go to completely shaded mode like this, then it's not transparent anymore, or technical, or maybe even rendered mode, then it looks like this. Yes. So that was a little pause in what I wanted to say. Here we have layers as well. So this one is in the layer default. But how do I see that, right? Well, if you go to properties, the layer is shown. So default layer, for example, here, you can also swap this layer, so you can put it in something else by pressing layer 3 with the right mouse button, change object layer. And there's a lot of different settings that you can use here for the layers, which we're not gonna go into that much now. You can, for example, rename it my layer. And then you can also actually delete the whole layer and take out everything there if you want to. So you should try out a little bit on this layer here. Of course, we can also add materials. We can also go in and change the render settings and so forth, which will be dealt with in later videos. On my left side, I have all my tools here. And this is the default setting here. In Windows, mind you, if you're using a Mac, this will look slightly different, more in a quadratic shape like this, and the command line is underneath the tools. Between the viewports and the command line in Windows, we have here is more settings that of navigation, and about the layers is also here, the properties is there, and we have we can save here, you can open the document and so forth. It's like shortcuts, all of it. So all of these icons are shortcuts actually. You could also always write them in the command line, like save, for example, you know, everything comes up there. If you are using a different language setting in your Rhino now, you will notice that if you try to tape save, some other suggestions comes up based on your language, right? But you can always override that in that you press underscore before you type. So save, and then the English version will appear, as a matter of fact. Yes, so we have, for example, if I draw like 3 cubes like this, the cubes, I just click this box right here, or box, or yeah, okay, cube is a different geometric shape depending on its properties, but if you click left mouse button here and select box, you can do something like that shown here. So we have some very interesting and useful commands up here actually. You see I'm rotating right like this right now. Maybe I want to work exactly on this object. Then we can go to zoom selected here. It's a magnifying glass with yellow objects in it, which means you zoom selected objects because everything is selected in Rhino turns yellow. So I click it, and if the perspective viewport is active, selected, then my selected object will be zoomed in on if I use zoom selected. If I right click, it does the same thing for all viewports, something like that. Could be quite handy if you have quite much objects there. So now you see when you rotate, it rotates around the object itself. If I want to see everything in one instant instead of just scrolling with the mouse, you know, like this, then you can go to zoom extents. It's the same thing there. Then I see all the objects I've drawn. If I click right on the same icon, the same thing happens in all viewports, like that. Another good thing which I often use is zoom target or zoom window. Zoom target is a right click. So if I right click on it, I can work on one exact little corner and rotate around that corner. That is indeed very good, because then you can, sometimes when you zoom in, it can be quite stressful. In this way, it's very very accurate and starts rotating around that point, right? Okay, so now we have a couple of boxes there, but I jumped to the boxes quite fast. We have some other modeling tools to look at before. So we have the very first one is of course the selection tool, which is default there. Every time you try and press escape or leave one of the commands, the select button will be there anyway. So you can select stuff. That's the white arrow. Right to it is a single point or multiple points. So you can, if you press the left mouse button, you can set a point somewhere around here in the viewport, in one of your or in front or top or whatever. And you saw now that I just put it with the mouse, right? But you can also do in the following manner. You press it, and then you simply type where you want to have it. For example, 15, 15, 15. Then it, of course, draws the point exactly in that coordinate position that I typed in, meaning X, Y, Z, right? 15 for X, 15 for Y, and 15 for Z. Usually, or very often, you want to draw in the very center of the X, Y, Z working space, because this is X, the red line, the green line is Y, and perpendicular to both of them we have the Z axis, which is not really visible here, but we can show it like this. This is the X-axis going up like that. And you saw also that I typed it in right now. So every time you draw a line of some sort, you can also type. But first of all, the point, location of point object, if you want to draw it in the middle, like I said, you don't have to write 0.0, you can just type 0 actually. So 0 and then enter. Then it understands exactly what you want to do. Now it's in the origo of my workspace. Yes, so the points can be drawn like this, or right click, you can draw multiple points, and right click again to exit the command. Now we can have these as support points, right, when you build something. So if you go to the next one, polyline, you might not have the snap system enabled. So for example, end means that you find the end point of something, it snaps to it. So you know that you exactly hit that corner of the boxes that I'm showing now. Near would be anywhere on the side of it. Mid would be in the middle, for example. Point would be on a point. There's no points there, but here is a point, so you can snap to those. So you have to make sure that these are clicked in, that you have a you see that they are on enable like this. Near could actually be quite annoying sometimes, which means you could miss with the mouse, right? So I can click that out. So here I have point enabled, so then I can go to all the points like this and join them in a polyline. So polyline is a 1 degree curve like this, which means it has straight connections between every point or time you click. And as you can see, I don't really need the points. I can draw wherever I want to. And every time I select my line in Rhino 6, it actually visualizes all the points that are there. Even though you didn't pick a particular point and draw it, they are actually, the line is constructed from points, so you can visualize the control points immediately. If you grab one point, you can transform the line again like this. Yeah, so I can take those out and go to the next one, which is actually a control point curve, which is also sometimes referred to as a spline or a interpolation curve. So you have a lot of different curves here. And this is more or less the same thing that we just did. The difference is that it's a 3 degree curve. So if I choose this one and go to the same points that I drew before, you will see a slight difference. And now if I click that one, you will see that the interpolation curves are exactly the same, right? That's the control points for this NURBS curve. And if you start transforming that, you see that it's actually interpolated between the control points. Yes. I urge you to check out all the curves here, actually, to draw them. And then when you go a little bit, when you have done a couple of surfaces also, you can actually also try to use, for example, sketch on polygon mesh or interpolate curve on surface. That means you're drawing on a surface actually directly. You also have spirals, you have a helix, which is a 3-dimensional spiral, and so forth. If we go further on, we see we have circles here, for example, as well. That is, then you click it. If you click this symbol, by the way, it means you will choose the very first one in the series of options that you have if you click the triangle in the edge here. The command line asks you something. Once again, center of circle, that's what it wants to know. That's what you have to answer with the mouse or simply type in. So answering with the mouse is the same thing as typing it in the command line up here. For example, I want to have it here, and then it asks something more, radius. If you have drawn something before, I will use the radius. Obviously, this is what I drew the last time. I used a circle in Rhino. So you can swap between radius or diameter. So I can more or less choose that with my mouse if I want to. I mean, I can go to the end point or snap to something like that, or I can simply type it in. You see here it's the last radius that I typed in. So if I write 10, now I know it's a radius of 10, width of 20, like that. We have the same thing for ellipses here. So then you just simply build it from an axis. You can see here in the command line it asks first where's the center. I answered already, and then the end of the first axis. And I press it like that, and you see that it's building it up. We would have some control points already. Now you notice probably that when I drew, I made a straight line, right? Maybe you want to have an exactly straight line. Then you hold shift, which means you will get straight lines like this. A shift like that can always be there constantly if you choose ortho down here, or in Mac it's another place. along the x-axis and the y-axis here in the workspace. So, but I urge you to have that not selected, and when you want to have it, you can simply press Shift. I'll have a very large ellipse. Yeah, I'm gonna tidy up here a little bit. Another very interesting thing you can do in Rhino is that you can build circles from points. So if you right-click on a point and click a lot of points like this, you can simply select all those. If you go to the triangle and take circle fit points, select points to build a circle or build a circle from. It says here in the command line, then you simply select all the points relevant to you, and it will build an approximation from it, which is very handy indeed. Because you will notice that when you draw, because the circle is always flat, for example, which will help you to orient things, but that's for a later session. We also have arcs here. Same thing, center of arc, start of arc, and then you can draw like this, for example. We have rectangles, corner to corner. You can also check what it's about. Rounded rectangle or normal rectangle, and then you can choose options. So if you choose that one, first corner or rectangle, then it simply means where do you want to start. I can press 0, for example. The questions continue. So 3-point or rounded. If you click rounded, it's very something that's very useful. Then you tell it already that it's not supposed to have sharp corners. So you see a preview from sharp corners, and then another option comes. You can type it in, the distance. That's the radius of the half circle, which is being built in the corner. So you can just simply do mouse like that. Another thing is that if you want to repeat a command, you simply right-click, or somewhere here, then you see the rectangle starts again. Or you can simply right-click in the command line anywhere. A whole list of last commands comes up. So you see here almost like a history of what we have done so far. So if I click again and don't choose rounded, then it becomes a normal rectangle like this. Yes, and we also have polygons. Cascade polygon here, for example. Polygon from center and radius. If we click that, it will have a default side number of 5, which means it will become a pentagon. And it's drawn actually like a circle, actually. So if you first it's asked for a center and then the distance to the corner, like this. So if you see, I'm drawing everything now in perspective mode, by the way. If I click enter again or right mouse button, the command comes again, and I can simply click number of sides, and then I take 3, for example, and it becomes a triangle. Yes, and mind you, I just said that these are actually circles, so you could do the same thing with a circle like this, and then we have a command called rebuild curve, which is also to be found on. That is a little bit more like advanced tools that you can find here in the curve tools, for example. Then you transform things after they have been built already. So depends on individual taste, I would say. If you want to. You can hover all of these, and depends if you want to, if it's better for you to remember the icons or the command itself. Either you remember the icon or you remember the command. It's called rebuild, and that's actually for in my case, I rather go for typing in this case. So I swap between typing and choosing an icon, and I must say I usually type the most. So rebuild, select curves, extrusion or surfaces to rebuild. Then you answer the question by selecting the curve you want to rebuild, and you click enter when done, and then a little window comes up like this. point count, and I can see a preview what's gonna be like. 6. You see it's already turning it into a hexagon. So if I go down to 3 preview, you see preview again. If I go up to 4, it turns into a square, and so forth. So that's also the same thing with the curves before. This is the difference between 3-degree curve and a 1-degree curve, as well as a 2-degree curve in this case. So you can swap between degrees, and you see a huge difference, especially from 1-degree curve to a 2-degree curve, of course. There you can also then transform it into a completely different shape, like that. So now I jump to the curve tools, and I really urge you to look into all of these, of course. This is where you transform the curves afterwards. This was one example. Standard, we go back to standard view again. So you have these options visible. If we go to fillet, here is a fast version of the same thing we showed. It depends if this is visible on your screen or not. So here, fillet curves, for example, then you can make a rounded corner somewhere. Select first curve to fillet, radius 1 maybe, and you click on 2 curves and it turns into a rounded edge like this. Might have gone fast. So if you click fillet curves, radius, it's a little bit small, I can take 10 instead. Then you click somewhere on one side of the corner you want to make round, and on the other one, like that, for example. Yeah, so I have a set of curves now, so we can jump into to the surface component. I can pull this out, and you can see a lot of different surface creation methods. The very simplest one, actually, maybe not the first one being shown, but this one, surface from planar curves. So if I click that, select planar curves to build surface, and I have a lot of planar curves already. You see, they are not in the set space at all. They have to be flat. So if I choose this one and click right click, it turns into surface like that. That is possibly the simplest way to make a surface. You can also make it from surface from 3 or 4 corner points. So you see, every time you hover, you will notice that Rhino tells you more or less how it's constructed, right? So if I click this one, I can put up to from 3 or 4 corner points. It builds a surface. I can also now just press enter, and it turns into a triangular surface, so I can continue, of course. The thing is, if I do this, if I draw this, I can delete this. If I draw this here as well, I press enter, then this command comes again, like that, and then I swap to another working viewport. You see, I just go over the mouse, and then I'm in front view, and then I'm in right view, and then the surface turned into something like this. It's actually bent. So you see the complexity of this shape. It's actually doubly curved surface already from this component. If we go on again, it's surface from network of curves. That means you have an outline, and you have some construction curves, and in a closed system, which I don't have on the screen right now, but I can draw it quite fast here. So now I built a curves network here. You see, there are, how many curves are there? There are 5 curves, side curves, and some section curves, so in 2 directions. This I did with only this control point curve. As long as it's a closed system, you can build a surface from this. So if I go to surface from network of curves like this, it says, the command line asks me select curves in network. And of course I urge you to pause the video and draw something similar and then simply follow what I'm doing. So then I select all my curves like this, and if there are no problems, if it doesn't have any more questions, it will look something like this. Rhino will try to build the surface that fits into all of these curves. And you can then have some options. So you see there's A, B, C, and D. And then for those curves, you can choose if they're going to be positioned, tangency, curvature, loose, or something. You can just simply swap between these. In this case, it's so close it won't actually be so much a difference. But depending on how you draw, you will see a difference when you click those different options. So now I have a quite complex surface here already. So if we go further, we have the loft, which is a very useful and often used surface. So if you go to control point curve again, we can, now I don't have to pause really because it's not so complex. For example, if I do 3 curves like this after each other, and then it looks a bit strange, right? So if I double click again here, if I double click, I swap between full screen perspective view and full screen, or top view, for example. Double click again, I see all 4 viewports. So if I, sorry, I'm pulling this a little bit to the side. If I move this in Z direction somewhere here, and then I go and I can just actually scroll with a mouse wheel in another viewport, then I type move, M-O-V-E, and it asks me point to move from. I already answered that, and then point to move to, I pull it upwards and I can actually hold shift if I want to. Then you see it goes up in Z space. The move command is also down here, by the way, so you don't have to type it really. So if I choose move, the system is going to ask me from where and to where I want to move it. So it's actually a vector movement to keep in mind. So it was somewhere, the start point, I can show it again with the next curve. I go to move, either here, directly click, or you type it up here. So you see in the command line we have geometry, but we also have move, copy and rotation and scale, and analyze and flip direction. We have rectangular arrays. So you see all the way down to let's say here somewhere, there's quite normal geometries. And then there are Boolean unions coming, projections. We join things, we explode things, we cut things, group things, and so forth. And then we actually, there are short commands for moving things, copying, scaling, and rotating, and so forth. So what I'm going to do now, I'm showing some of these, I select a couple of geometries to draw, and then we also quickly jump to the navigation things here to move them along a vector. So everything is controlled by vectors. Well, what is a vector? So I have selected my curve, I go to move, and the vector movement is actually from one point to another. I can click wherever I want to. I don't have to click exactly on the curve. I can click here, and that vector movement is translated from the object's position itself to another point in relation to what I do with the mouse wherever, if you understand what I mean. So first it has point to move from, and then I drew this in front view to be able to go in Z space. So you see already when I'm already on the start point, the object doesn't move at all, but when I pull up, it mimics the translation I'm doing here. That's a translation vector from this point to that point. And you see that it mimics the movement, of course. So I pull it up somewhere like that, and then we can start choosing, building our loft. Now double clicked again to the perspective view, and you see that they are lying like this in Z space. You can always move them actually if you want to rearrange it somehow. You can hold, for example, hold shift and go back and forth like this, like I'm doing now. So I moved it a little bit again. So let's say we want to build a curve through this ribs here, and that's the loft command. You can do it with others as well, but that's a very convenient one for exactly this purpose. So we go to loft, click that, and select curves in loft. Then it builds the surface from one curve to the other, so you have to choose which order they are. So I will start with the bottom curve, then the middle, and then the top curve, and then press enter when done. And then it builds a loft like this. Mind you, there can be some problems. For example, if I had drawn this curve in the other direction, I can swap the curve direction by typing flip. That means I start to draw it from this point to that point to that point to that point, and finally to the last point. If I did that the other way around, starting here, from this point to this point to this point to this point, the whole loft would have been changed. I can swap the direction of the curve by selecting it and typing flip. Flip the direction of one object. You see, the command line also answers if it worked or not. So it's quite much about, depending on which direction you drew or other factors. In this case, maybe it doesn't happen. We can see loft. Again, here if I, for example, flip this curve, I type flip. I change the direction of the object, right? And then I select loft and press it. Something weird happened. Look at that. I flip one of the objects, which means it actually tries to draw it exactly like that. This is not always the case, but if this happened, you can flip the curves like I did and try to do it again, or you can simply press align curves. Here you see it's crossed, and you can pull it back, like aligning where the end of the loft should be, and then it should be fine. So there I also have a quite complex surface. So you should actually go through all of these and try it out. For example, surface from 2, 3, or 4 edge curves is quite interesting. I can probably borrow some of these curves. If I move that out here, I have 2 curves, and I can build a surface between these, and Rhino will analyze the curves and build a wall between them, approximation wall. So if I click that and select 2 curves, it will make something like that. It looks pretty decent. That is what it should have been also. But if you add curves like this, it says also up to 4 curves, right? So you can keep that in mind, and then the surface will look completely different and analyze all 4 curves. See, that's a quite interesting shape. We can probably already imagine what it's going to look like, more or less, because it's going to take all of these curves into account. So let's go to select 2, 3, or 4 edge curves again. Select them. It doesn't really matter if you select them in what order. Here you go. So this would be the result of that surface of those 4 curves. I mean, yes. We also have here a rectangular plane, which is more or less exactly what it says it is. Simply a rectangular surface that you just draw on the very bottom, on the floor, so to say. So here we also have something interesting called sweep and sweep 2. So we can look at those as well. Maybe you will have something like this. So that's what it's called, sweep rail. You know, it's almost like a rail, and then you have your section curves. Maybe you have a section curves like this, and here you have a different section curve. Now I pressed near to be able to snap on it wherever. Maybe a section curve looks like that. You know, in the end you have something like that. If you choose sweep, it would use this rail, build the curve along it, but get help from these section curves. So, well, this is going to be quite weird surface, obviously. But let's try it out anyway. So sweep 1 rail. Now it's going to approximate the continues the change between these curves and build the wall there. So select rail, it asks first. I click that, and then select cross-section curves. It can be very many actually. So this one, and this one. And then I press enter, and it turns into this very strange shape. And then of course this kind of stuff happens with sweep 1. How can we take that out? It is actually a possibility in sweep 2 because it uses 2 rails. So then I can start drawing something more specific. For example, like this. See it now, it really, this is a bit irritating, of course. What can you do about that then? Now we get into things that are a little bit lower in the list. So we can cut that off, right? Using trim. And trim is here. It's a fast icon actually on the very main board, which also means that you use it quite often. So if you go to trim, it asks you again, select cutting objects. What do you want to cut with? You know, where would the knife go if you would cut this edge? So this would be the cutting edge. And then you right click, and then it's select object to trim. So press shift to extend. That's very uncommon actually, but here you can just actually cut that off. So if you click on the end you want to be gone, it's gonna disappear like that. So now we looked into trim a little bit fast there. So if we go to sweep 2 rails, it wants to know 2 rails instead of 1 like we did before. So I click it, select first rail, click, understood it immediately, you don't have to press enter in between. So, and select second rail, and then it starts asking for cross-section curves. So then I click these, and then it's gonna look differently than before. And you saw there was some settings there as well. You can look into them. So sweep 1, first rail, second rail, cross-section curves, enter, and then you can see that you can rebuild everything if you want to. Rebuild cross-section with 5 control points. You can write 50 if you want to, and that's how the preview will be. It's a much denser surface. That's all. So you can probably imagine that you can build quite interesting shapes with that. More interesting than the shape I built right now. So, and then we have also something called revolve. You have a rail and you can rotate things around them. We have something called drape, which is seldom used, I would argue. We can build a height field from an image as well. So if you have a JPEG for example, you can load it in and it would build a topography based on its black and white structures, so on its grayscale tones. You can also build a surface from a point grid here. So those are things that I want you to check into yourselves a little bit. I can close that now. We can go further. We can look into surface tools, which means you can fillet your surface, you can blend it. So if we, what does that mean? You actually a rounded surface edge. So we have here, for example, our boxes. So if I go there and I click and I said select first surface to fillet, radius 1, I can just say something else, radius 5 or something. So you can see it. And then I click, and it actually understands the components of the box here. And every time you see that it wants to choose something else, and I can swap between the surfaces I want to make active. So I'll take, for example, this one, and view, it actually turns into something like that. Now, of course, this is a bit weird on this very shape, but you can do it on all edges, of course. So you could do such blends on fillet on the edges, so you can make the whole corner actually, and not like we did before, which was a test only on surfaces. So if you go to the solid tools and open them, you can find fillet edges right here. And edge, what is edges actually? Well, that's the side, where the walls meet each other here. And the walls are not called walls really on a geometry, it's called faces. So if I explode this, I can explain a little bit better. So here you have one face, it's another face. Where they meet is called an edge. And the corner up here, that's called the vertex of a geometry. So now I went back, now it's solid again. You saw I can explode it, and then it's turned into 6 surfaces. If I go back again, it's one solid shape. So if I go back here to solid tools and go to fillet edges, Rhino asks me for edges to fillet, and I can also choose a radius if I want. I think 1 is actually quite good for this case. So I can, if I want to do this corner, for example, I will go select that one. It's actually showing the radius is going to be made as well. So I can swap radius if I want to. I can do 1.5 instead, for example. Now this is 1.5 and this one is also 1.5, and then it makes a mix out of those. And I press enter. When I press enter the first time, it actually shows a preview. So that means I can start changing all the radiuses here just by clicking with the mouse, right? Which is actually not what I wanted to do, but let's do that anyway. And then we can click enter again, and it makes an approximation of what I just did. So I can look at that in rendered mode, and you see how it turned out. Yes, so rendered mode, as you remember, you right click and you go back to ghosted there, for example. We can walk over to the solid tools, it's called solid creation, of course, I'm sorry. So here, box corner, we already tried that a couple of times. We have a cylinder as well. We have also spheres. Works exactly like the circle, more or less, center of sphere, and then I press somewhere and then let's pull, or type in a specific radius, and then I can make a sphere, like that. What do we have more there? We have ellipsoid. You can also try to draw this yourself. That would be great. So you have different shapes like that. We also have a cone. We have a paraboloid. We have a truncated cone. We have a pyramid. We have a tube that with a solid wall, actually. So you have 2 walls like this. We also have a pipe. But then, of course, you have to have a rail first, right? So any curve you draw, I have curves already, so okay. I'll just choose that one, and I go to pipe, and it wants to build a pipe around that curve, right? So either I can just type it in, the first radius, or I can do with the mouse like this, like that, and then the second radius comes. So you see, you can actually make it larger on the one side, and then I press enter, and it turns into a very weird shape like that. But of course, that is quite interesting to play around with. So if I press 1 and 1, again, start radius 1, end radius 1. Now it's more like a normal shape, right? So when you're building pipes like that, it's actually better it's always better to type the numbers that you want to use. That's more exact than just clicking with the mouse, unless you have a reference curve or something. If we go further, we have something very interesting called extrude closed planar curve. That means you extrude it in a direction of your choice upwards. So if we have a curve, for example, a closed planar curve, like it said, like this, I can go to, select it, and I go to extrude closed planar curve, and it goes upwards, right? Now you can choose solid yes or no. Solid yes will turn it into a closed shape if you look at render mode, like that. If I do it again with extrude closed planar curve and click solid no, it would be open, so it's only walls, as you see, like that. If we go further, we have something called Boolean union, which is very useful. So if I want to join these two into one solid shape, they have to, of course, touch each other, right? So I can move that into that one like this. You see that if I just select something and pull, I can actually move things. I don't have to move the whole time, but move when you type move or select the icon, it's much more exact, of course. If I want these to be joined with each other, if I go to ghosted mode, you see, you see that the shapes are still intact, right? This one is not joined with the other one. And what I mean with join is when you select both of them and click Boolean union. Rhinoceros calculates both shapes and turn them into one solid common object, so looking like this. Then you have some discrepancies, for example here. Why did this happen? Well, it has to use the floor of one of them, right, to do this. Ideal would, of course, be if they would share the whole floor. Then you would most likely have to cut that out and make it... in this case, I will actually explode it. Sorry. I would explode it and then draw a new floor underneath to be more exact about this. Which you then can do with something called dup edges. Dup edges. Dup edge. Yeah, select edges to duplicate. And you can select the whole floor like that. Turns into curves, and then you can simply go to the first command, surface from planar curves, and it gives you a new floor, which is actually looking quite much better. But then they're all open again, aren't they? It's not a closed system anymore. So then we can already jump down to this join, and that can be join curves or surfaces or whatever you have. So if I click that, join, select object for join, it says in singularis, right, but it actually means plural, so you can have quite many. Curves, surfaces, and polar surfaces must be open. Yeah, that's true, because otherwise they are closed, so you can't use them. So if I just select all of these, you can select multiple in this case. I could have selected all of them before, of course, and then clicked join. Like that. Now it's a joined shape again. So the other way around, if I go back, now they're not joined, and I select all of them, then I click join, it joins them immediately, so you don't have to click every individual shape. So those are joined now. So what about if I want to cut something out? I can use this box and cut something out here. And that's more or less the inverted operation. That's Boolean difference. So if you click this one, select surfaces or polar surfaces to subtract from. That means from which shape should I be cutting something? And I would say it would be this one, and then I can select more if I want to. But if I'm finished with that selection, I press enter, and the command line asks you select surfaces or polar surfaces to subtract with. And that's what's going to be cut away from the whole system. So that it's this shape. Now this one is going to disappear actually. So I select it and cut this opening there. Another one. Now I went back again. So there's also something called Boolean difference. Intersection. And there's also something called Boolean split. So if I take Boolean intersection, you see already on the icon what's going to happen, right? The room in between these shapes are going to be saved. So if I click it, select first set of surfaces or polar surfaces. Choose this one, enter, and second set. No, only this part is going to be remaining, you know. So you should try that out a little bit with different shapes to understand how it works. And the last one is going to cut as much as possible, more or less. So if I click Boolean split, select surfaces or polar surfaces to split. Delete input, yes. All right. I want to split these, select cutting surfaces. Now we have more or less everything, right? This one is there, still there. This one is there, and this one is there. So it depends on the situation which Boolean system you're gonna work with. Yes, and then we also have something called curve from object. You can project curves onto shapes. For example, if I have, let's say, I draw something in the top view here, I make a, let's say I make a circle like this, and I move it. Well, I want to move it on top of this. So a little smaller circle, I move it where I want to have it, and then I can go to project and click there, project curves. So select curves and points to project. I select my circle that I draw. I can select more of them, and I press enter. Select surfaces, polysurfaces, or meshes to project onto, and I choose my very doubly curved surface that I made previously, and press enter, and voila, the circle I just drew is projected onto that shape. Then I can of course use that to cut a hole or something like that, which means we are moving to split and trim. So if I want to have a hole, I can choose trim, select cutting objects. That means where is the path that the knife, so to say, or the scissors is going to go. That would be my projected circle. Okay, so then I'm fine with that. Then I press enter to tell the command line I've chosen it. I've finished choosing. Select object to trim. Then you have to, of course, click somewhere within this shape. So I click there, and then it turns into a hole like that. Then again, you might want to keep that shape, right? So if I go back and I go to split instead, that means both of these surfaces, I mean the little one, the small surface inside the circle, projected circle, we're going to remain, and the other one as well. Then I go to split, and then it asks kind of the other way around, you know, like select objects to split. That would be my surface in this case. And I can actually choose quite many of them, but I only have one now, so I press enter because I'm finished. And then select cutting objects. That is, again then, where is the knife going to go along, or the scissors. That would be my projected circle here, so I click that and press enter. And then it's already finished. Then you see you split this surface into two parts, like that. So I also urge you to try that out with the different shapes. Of course, you can do that also only with curves. If you go to top view and you have a curve, for example, like this, and you have a curve somewhere on it, you can use trim. We did that before as well. Select cutting objects. That will be my knife because it actually touches the surface. I press enter and I can cut that off, right? If I go back, it's the same with split. Select objects to split would be this line. Then it asks for the scissors. If I press enter, select cutting objects, and this is the line. So now it's divided into two parts like that. Yeah. If you want to group things, if we go down here, we have group and ungroup objects. So if I want to move all, I mean, if I pull the mouse from the right lower corner to the top left corner, I can select all of these. If I pull the mouse from the left bottom corner to the top right corner, I select only what is inside the window, meaning these two curves. If I pull like this, everything it touches on the other side, if I pull from the lower right corner, everything the window touches will be selected. So this means, of course, you can sometimes forget, you miss the stuff when you move them away if you have a lot of objects. Which means you can select all them on beforehand and press group, and then they are grouped in one group. So anyway you click, they are grouped then. And then to get out of that, you can press ungroup. And the fast command for this is Control G. So now we're grouped, or Control Shift key to ungroup them. Group is something that I actually do not recommend to use too much, because when you export it, it can lead to some problems. So explode and joined, maybe you have tried that as well. I mean, I can try it on my curves that I have. I'll go to perspective view to show that. I can rejoin these surfaces if I want to. So if you want to select more than one object, you press shift. You know, because if you don't press shift now, I'm just going to select two objects. But if I hold shift now and select, then I have selected two objects. Then I can go to join, and these are joined into one surface again. If I then go to explode the other way around, then they are separated again. The same thing could be made with curves. So if I want to join, for example, these curves into one curve, I press join or type join. Now that's one curve. If I want to, so to say, undo that, but not from this one, like not from Control Z, I can explode them into their component parts. So it's now it's already back to how it used to be before if I press explode. Down here you can also visualize the control points, which is actually something which is in Rhino 6 already visualized. So it's more or less the same thing. If you press escape, they disappear. The difference though is this. So first we see the control points that control the curve's form like that. You can also have control points directly on the line, which is then this icon to left. Show curve edit points. Then it actually hits the curve exactly. So in the background now, the other control points are of course also still there. But this means you can actually pull back and forth with a little bit more exactness perhaps, if you want to, depending on what kind of curve you have. So to exit that, you simply press escape, and that disappears, and then you see that the control points actually look like this if you would consider the relation to a 1 degree curve, like a polyline going up here. Then again, you can also write texts. You can move objects. We have gone through that, and you can copy objects. If you click copy, select objects and copy, press enter when done. I want to copy this one, and then I can continue, you know, how much as I want to. To stop the copy command, you have to right click or press enter, then you're finished with that command. You can also rotate things. So on rotate 2D here, for example, select objects to rotate. Then you must keep in mind, it's going to start asking a question, where is the rotation point and what is the degree you want to rotate with. So I will choose this one. Press enter when you're done. Center of rotation. Then you can click somewhere, and around that point it will rotate. So if I click on the corner with, of course, end, a snap enabled, then I get this preview of rotation. So angle of first reference point, it wants to know from where it should start to rotate, right? So you can click wherever, more or less, depending on what you draw. So I click there, and then now it wants to know the angle. So now you can either type that or simply choose it with your mouse. And remember that everything, according to mathematical rules, positive value goes to the left, like a counterclockwise rotation. Negative goes to the clockwise rotation, to the right in this case. So if I press, for example, 45, it will be like that. If I do this again, and I press minus 45, it will go down clockwise. You can also scale things here. You have a quite good scaling version. This is something This is something I use quite often. So this is 3D scale, which means the shape will just grow in all directions, like this. All right. If I go back, and I can show you instead 2D scale. That means it would only scale in X and Y direction, because I'm in the perspective viewport. And the perspective viewport is controlled by the top view actually, so it means that X and Y, that's the main, that's where all these commands are being executed. So select objects to scale, enter, and then we can see something completely different. So we have a reference point of scaling, and then we start again, and you see it actually stretches. It's exactly the same size in the Z direction as before. It just scales in the XY direction. So that's a 2D scale because it only uses 2 axes, right? 3D scales is using 3 axes. So here in scale 1D, we can scale only on 1 axis. So now it stretches along the x-axis like that, not in 2-axis system. Yes. Then we also have something called array, which is quite good for making grids. So if I just move all this away, let's say I have a rectangle in 0. I press 0 to position it there. I can go to array, select objects to array, and it starts asking me quite many questions here. Number in X direction. It's going to turn into a chessboard more or less, but well, it's not quadratic, but you see the point. So I can type, for example, 10 in the command line. Number in the Y direction, 10 as well. And if I wanted to go up also in Z direction, I can do that. So, well, I can show you how that looks like. So 10. So unit cell spacing. How far away from each other should they be? Like that. You see, if you click then somewhere where you start and where the end position is going to be, you see a preview already. Let's say it's like that. And then it also, since I typed in 10 in Z direction, it's going to ask me that as well. So then I can turn it into a big grid like that. And it turns in actually pink. It's because it's a preview. You have to confirm that you want to have this. Otherwise you would just press escape. You know, so enter once more, and then you have the all the all the curves built like this. Usually I would say, if we do it again, select objects to array, you press 10 in X direction, 10 in the Y direction, only 1 in the Z direction. That means it's not going to grow in Z direction if you don't want that. So then it just turns into something like that instead. Of course, this is a static system, and if you want to know, you can't really change the distances between them and the numbers in each row, and that's why Grasshopper has been also developed to have all of these shapes that we draw already changeable throughout the whole design process. So that will be the next video, the intro to Grasshopper. Thank you for watching.